Okay, we are going to look at now calculations involving these equations. Now, this is where I want you to understand. Now, the first thing always you are going to do, read your question. That is the first thing. Now, when you read our question, they are telling us that we have a car, assuming this is our car. And when you look at our car here, they are telling us that a car accelerated from a velocity of 10, meaning that initially the car was started with 10. And then it went, and this is where now our car is. And here it has a velocity of 30 meters per second. But how much time has it taken? It has taken 4 seconds. Now you first summarize. Now I'm going to first summarize. Members, let me know. When you look at 10, remember we said we have what we call initial velocity and we have what we call final velocity. Members, when you look at 10 and 30, what is our u and what is our v? What velocity did the car start with and what was it having after the 4 seconds? So what is your u and what is your v? Put in the chat and I see now. I've started now testing. Are we understanding? What is your u and what is your v? What velocity did the car start with? Husna said u is 10, v is 30. Very good. Thank you, Husna. That is very correct. So the car initially had 10 meters per second as its velocity. So in my summary, I'm going to say my u is 10 per meter second. Then what the car finished with in the 4 seconds was the 30 meters per second. Then how much time did it take? It took 4 seconds. Now, in order for me to calculate acceleration, remember we said that acceleration is given by v minus u out of the time. You remember? Then what we are going to do, we are going to substitute. Where there is v, we put 30. So I will say 30 minus the 10 out of the time, which is 4. So here we shall have 30 minus 10 is 20 out of 4, and 20 out of 4 is 5. But we have said that acceleration, the SI units, are given as meters per second squared. Then, members, is that fine? Let me know through the chat. Is that okay? Is that okay? Anna said yes. Okay, I think it is well. Very good. Ellie? Ellie? Okay, Ellie?
Teacher, when we are talking about number 2, the second part, can distance be regarded as also displacement?
Yes, but now the only difference is that here, in displacement, we look at the direction. But here, since they have asked us for the distance, we shall consider it in form of displacement. Is that okay?
Yes, but I had seen something in my textbook giving the similar formula to what you gave us, but they said distance traveled. So I just wanted to know if it was correct or it was a misleading textbook.
Oh, okay, yes. Now, but here, when it comes to equations of motion, whenever they tell you distance, they're referring to displacement in most cases. The only difference that when they ask for displacement, but here, if they had said the distance moved by the car. Now, when you look at this car, is taking on a given direction, Though they have not mentioned that direction here.
Yes.
So when they talk about distance, they are referring to displacement because you are not seeing, even they have used velocity. Whenever they are using velocity, it means they are referring to displacement.
Yes.
Okay. Now we go to part 2. They're asking us distance moved by the car. So we shall say that our displacement is going to be ut plus a half at squared. Now our u is the initial velocity, which we have as 10 times the time, which is 4, plus 1 out of 2 times acceleration, we have obtained it as 5, times the time, which is 4 squared. Now you'll continue. 10 times 4 is 40, plus 1 out of 2 times 5 times 4 squared, which is 16. Now you can do your mathematics and say by 2, 1. By 2, this is 4. Now you'll continue and say this is 40 plus 5 times 4. But 5 times 4, no, sorry, by 2 and this is 8. I don't know why I wrote 4. This is 8 by 2 and by 2, 8. So this will be 40 plus 5 times 8, which is also 40. So you'll end up with your answers 80. But the SI units are meters for our distance. Are we together, members, on that? Is that okay? Let me know through the chat. Are we together? Okay, Hosna said yes. Ellie is okay. Okay, very good. Okay, great. Okay, let's write now. Members, let's write. Venus. Venus, it seems there's something you're not happy with. Venus, can you unmute? Venus, unmute. Okay, Venus, we are fading. Yes, Irina?
So I'm wondering, to find the distance moved by the car, is it okay to use direct method of finding the displacement?
What is the direct method? Average velocity?
Yes, times
Yes.
that time. And I still got the same answer as you.
Yes, it is the same. You get the same answer.
Okay, sir. Thank you.
All right. Okay, when you finish, you let me know. Yes, Ellie?
In case of being given units that are not seconds, should we convert?
Yes, exactly. Here we deal with standard units, but I'll talk about it in one of the examples. Like in case they are standard units, you would work out in standards. In case you find one measurement is in kilometers, another one is in seconds, then kilometers go with hours strictly. Meters go with seconds. So you make sure that you work with those units.
Okay.
Yes, Daniel?
Teacher, what if all the units that they have given here?
I beg your pardon. I'm not getting clear. Daniel, come again. Oh, I've failed to. Okay. I think members have finished. Eddie, is it a question?
Yes. Here, do we say that every square kilometer, that every square second that passed, 5 meters were moved?
Every
square second, every square meter. Because at least when we are talking about speed, you say that for every 1 hour, 5 kilometers were moved. So I'm a bit confused on how you can say that.
So here, yeah, Okay, I think I will talk about it. I know what I think I'm picking what you're getting. Like the way you say, when I say 30 kilometers per hour, what does it mean? It means that in every 1 hour, you are covering 30 kilometers. That is the meaning. So when we have meter per second squared, when you have 5 meters, it means that in every 1 second squared, you covered 5 meters. Something like that. Hope it is okay. Okay, we go to another one. But Eddie, let me know whether it is okay.
Yes.
Okay. Okay, this is our second number. Still now, the first thing you do, first summarize. Look at the question, ask yourself, what have they given us? So when you look at the question, they have given us that a body moving with a velocity of this accelerates to a velocity of this in 5 seconds. Now, you ask yourself, but this is the same number we have done, not so? Oh, it is different. Oh, it is different. Now, the first thing you do, first summarize. So I'll say a body moving with a velocity. So initially it is 20. So I'll say my U is 20. My V is equal to 30. My time T is 5 seconds. Now, after summarizing, you can go on and calculate. So Roman 1, acceleration. So you know that acceleration is given by V minus U out of time. Ask yourself, have all those quantities been given to you? We have V, we have U, and we have time, meaning that we are going to substitute. So I'll say my V is 30 minus U, which is 20, out of the time, which is 5. Then I say 30 minus 20 gives us a 10 out of 5, which will give us 2 meters per second squared as our acceleration. So that is the first thing. Yes, Bera?
Teacher, I was requesting to take us through, but
Okay, take us through number 2.
all
Roman
right.
2.
So distance moved is still the same as displacement. So displacement is seen as S is equivalent to the initial velocity, which is U, plus a half of acceleration.
Okay, UT plus a half of acceleration times T squared, okay?
Yes. So we are going to substitute. Our initial is 20. Our time is 5. Plus a half of our acceleration, which is 2. Then time is 5.
But
So the
squared, eh?
yes, squared.
Okay.
Then that is 100. Then the 2's cancel each other and you remain with 25.
Okay.
Yes, then you get 125
And what are the units?
meters.
Meters. Thank you. That is very okay. Better. Can you also take us through the third one? Who wants, let me ask, is there anyone who wants to use the third one to get the same answer? Any that wants to take us through using the third equation? Okay. Okay. Bella, do you want to take us through using the third one?
Yes.
Okay. Or alternatively,
Our third equation is velocity squared, the final, is equivalent to the initial squared plus 2 acceleration. Then, yes. So our final was 30 squared plus 20 squared plus 2, our acceleration was 2 also. Then S we don't know, yes. So that is 90.
90. Sure? Is it 90?
Oh, 900, sorry.
900.
400 plus 4. Yes. So we subtract 400 from both sides. You remain with 500 divided by 4, which is 125 meters.
120. Okay. Yes. So members, you can use any of these, or even there, I know there are people who want to use that S is equal to V plus U out of 2 times time as their displacement, whereby you say your V is going to be 30 plus that is what, 20 out of 2, then times our time, which was 5. So this will give you 50 out of 2 times 5, which is giving us, this is 25 times the 5, which gives us 125. So you can use any that is easy for you, and then you have the same answer. Okay. Members, are we there? Are we on the same page? Yeah. Okay, are we good to continue? Should we continue, members? Let me know. Should we continue? Paper saying yes, good. Okay. Okay, can you first write that? And then we start. I feel we are there. Okay, now we start. The first thing always summarize. Maki. Maki. Maki, unmute.
I wanted to try it, but I'm not sure what I have is correct.
Okay, we can start, no problem. Okay, take
All
us.
right. So I interpreted the question, and it says a car was moving with a velocity of that. So I want to take that as our initial.
Very good.
But then it retards uniformly at a rate of that. So I want to call it deceleration or retardation.
Very good. So that is our A.
2.5 meter.
2.5. Very good. Now, what are you going to how are you going to show that this is retardation and not acceleration?
With a negative.
With a negative. Very good. So here, members, please take note. We shall put a negative. So this negative is the one that shows us that our speed is decreasing. When they talk about retardation, it means that your speed is decreasing. Your velocity is coming down. Okay, we continue.
Yes. So they want us to find the final velocity after 8 seconds.
Okay. And t is equal to 8 seconds. Okay.
So we are going to say acceleration is equivalent to the final minus the initial divided by time.
Okay.
So they will have negative 2.5 meters per
Okay. May
square
I
second.
request? Okay. Negative 2.5.
Then the v we don't know,
Mm-hmm.
minus the initial, which is 25,
Mm-hmm.
divide by 8.
Okay.
So we multiply 8 on both sides.
Mm-hmm.
And that will be negative 20.
Negative 20 this, eh?
Yes.
Okay.
So we add 25 to both sides.
Mm-hmm.
And we'll get v as 5.
Okay. So 5 is equal to our V. And what are the units?
5 meters per square seconds.
Oh, velocity is not per square, is per second.
Oh, sorry.
Is that okay?
Yes, that's what I
Okay,
have.
Mark, you first set for us the first equation of motion.
Pardon?
How do you set for us the first equation of motion? V equals?
Oh, v equals u plus 80.
Okay. Can we use this as well?
Yes.
Mm-hmm.
So v, we don't know. U is 25 plus negative 2.5. 8.
Okay.
So it's 25 minus 20.
Yeah, which gives us? So thank you, Maki. So Maki, your answer was correct. I don't know whether members were on the same page. In case you have a question, kindly ask before when Mark is still on. Yeah, so you can use any of those two approaches and then, yes. So we have said that retardation means a decrease in the velocity. Yes, whenever the velocity is reducing, the velocity is coming, like whenever the velocity is decreasing, we say you are retarding. Yeah, an example is that sometimes when someone is maybe running around a field, you can start very strongly, but after around 5 rounds, you feel you're a bit tired. So you start retarding, you start decreasing on your pace you have been moving on. So that is what you call retarding. Even in life, even you have seen an example is that whenever your parent, those who have cars, whenever your parent sees a traffic officer, the first thing the parent is going to do is going to retard. You'll see him holding all the brakes because now he's in fear that maybe it's a mistake or what. So you'll find them reducing their speed. So that's what we call retarding, like that reduction in the speed. Okay, now we go to the next one. Time it takes to come to rest. Members, I want you to put, when we say that you are coming to rest, what is the final velocity? Someone who has been running and now you are coming to rest. You are coming to the finishing point. What is going to be your final velocity? Put it in the chat. What is going to be your final velocity? Put it in the chat. Martha has said 0. Very good, Martha. That is very important. And that one, for you to do number 2, you needed to know that part 2, that whenever someone is coming to rest, someone is coming to the finishing line, his velocity comes on and decreases up to 0. So here the keyword was coming to rest. So meaning that the final velocity V is equal to 0. So they're asking, how much time did this person use? So we shall still go back and say, that one we can do. So we can still say V is equal to U plus AT. What is important is you knowing that V is 0. So I will say 0 is equal to initially this person had 25 plus acceleration was negative 2.5, then times our time. So this will be 0 equaling to 25 minus 2.5 t. But since we want t, we can take it this side. So I'll have 2.5 t equaling to 25. So you divide by 2.5, divide by 2.5. And therefore your t will equal to, so you divide 25 divided by 2.5, you get your answer. You get your answers 10 seconds. So meaning that this person took 10 seconds to come to rest. Mark, any question?
No.
Okay. Or you wanted to take us through the last number?
Yes.
Okay. Okay, take us through the last part.
So we're going to find this distance moved by the car using the pad, which is velocity squared equivalent to the initial squared also plus 2as. So our initial velocity, our final velocity was 20.
Our?
Our final velocity.
How did you get 20, marking?
Oh, sorry. It's 25.
What is that? Final initial.
That 25 is the initial.
Okay.
Two of the acceleration, which was 5. It was negative 5.
Okay. Negative 2.5, eh?
Yes.
Okay.
So then we'll have 500.
Okay. Don't not forget that now this one is going to be 0 because the previous question they told us that this car came to rest. Is that fine?
Oh, yes.
Okay. So here we shall have 0 is equal to
625
hmm,
plus, oh, sorry, okay, minus 5s.
okay.
So we subtract 625 from both sides.
Okay. So this
And
is
we,
0. Mm-hmm.
and we divide -5 on both sides.
Okay.
So you get 125 meters.
Yes. So that is what you do. So you can make, so please make your S, my S I'm trying, but make it a bit better, yours. Okay. Thank you, Maki. So that's what we do. So that is what you have to do. So, but in case you don't want to use this, then for you can go and say, for me, let me use this. That S is UT plus a half AT squared. Then now for you, we do your initial was 25. And how much time did the car take? It took 10 seconds plus a half times the negative 2.5, then times the 10 squared. So when you do the mathematics, you'll find yourself that here, you'll get your, this is about 250. Then this is going to be 10, but you do the mathematics, eh? You do the mathematics. So you'll find, you are going to find that this one is going to be, I think, minus 125. And when you do the mathematics, you'll find that also here, you'll get 125 meters. So any of the equations you use, you'll end up with the same answer. What is very important is for you to play with the mathematics. Once the mathematics is correct, then everything will be fine. Members, let me know through whether we're on the same page. Are we on the same page? Okay. Yes, and please, I want to warn the people who are just talking in the chat, to please stop and then you focus. Otherwise, we shall throw you out of the lesson. Yeah, you need to be more responsible. Where is the negative coming from? The negative comes from the statement that was mentioned that the car was retarding. So being a retardation, we used a negative. So acceleration is negative. Okay. So when you finish, members, you let me know. Okay, members have finished. Okay. Elena and Emanuela, you can unmute.
So my
Sir,
question,
Yes.
let's
my
Emanuela
question
first.
is, okay, I've not understood the part of the zero when it
Which
comes
is
to rest.
when it comes to rest, eh? Now let me
Mm.
ask you. Imagine you're like the parents are driving and they find a policeman. What do they usually do? And the policeman stops them. What do they usually do?
They stop.
There is what is the speed at that point when they have stopped?
Zero.
Zero. Now that is the zero you are seeing. Because they told that now they are coming to rest. Coming to rest means like as if they have found a policeman and now they have to stop. So whenever you stop, your final velocity is zero.
Okay. Only if they give come to rest is when the velocity, the final velocity will be zero.
Yes, or if they specify.
Okay.
Hmm.
Thank you.
Okay. Yeah. Yes, Elena.
So my question is that in case it is a paper, will they give us the three equations when you're answering, or you're supposed to go when you already know them in the head?
You must know them in the head.
Okay.
Hmm. Okay, first write that. Okay, Zara,
Good afternoon, teacher.
good afternoon.
I'm sorry, teacher, but I am having difficulty in answering the third question. I have got confused and I have stopped and I'm behind currently. The third question, where distance moved by the car.
Which equation are you using?
I'm using S equals to initial velocity plus initial velocity times time plus a half acceleration times time squared.
Mm-hmm.
I'm getting an answer of 350 like that.
Did you did you use negative 2.5 for your acceleration?
Yes, I think that's where I made the mistake.
Yeah, because remember, it is negative.
But teacher, why is it negative?
Like we have said, the car is retarding. So when you are
Yes.
retarding, it means that your acceleration, it means that the velocity is reducing. So accelerating means velocity is increasing. Deceleration means the velocity is reducing. So since they told us it is retarding, that's why we call it a negative. I don't know
Okay.
they are getting it.
I'm getting it.
Yeah, so that's why we use the negative. So whenever you find that it is retarding, it is doing what? Then it means
It's a negative. Okay.
yes. Okay, so members, now we go in for another one. Now, what is important for this one? One thing I want you to notice that you are noticing that they have given us things in different units. They have given us kilometers per hour and we have seconds. I want to let you know that kilometer and hour, they go with hours. Seconds go with meters. So meaning that you always have to convert them into the matching units. So what do you do? Now I'm going to first give you a brief. Now, when you have kilometers per hour and you are taking them, you must take them to meters per second. When you find that what you have is in kilometers per hour, you take them in meters per second. But like you know, and Anderson, okay. So like you know that kilometer per hour means kilometer out of an hour. So what are you going to do? Now, if you find yourself, let me say you have 90 kilometer per hour. You go back, you remember we said that King Heldy died, many dogs, I think, cried much. Now you ask yourself, in case I want kilometers, this is what we do. So I'll have 100, meaning that in 1 kilometer, how many meters do we have? We have about 1,000 meters. Now you ask, meaning that I have to convert the kilometers to meters. Then the hours, I convert them to seconds. So in 1 hour, how many seconds do we have? In 1 hour, we have 60 minutes. But in 1 minute, you have 60 seconds. So I'll say that now in 1 hour, I'll have 60 times 60 seconds, which will give me 3,600 seconds. Members, let me know through the chat. Is that fine? Is that fine where we are now? So even someone I think has already obtained the answer. Okay, yes. Now what do you do? Since you are dealing with kilometers out of hours, what you do, you get your 90. I'll get my 90. These kilometers, I convert it to meters. So I say times 1,000 divided by the hour, I convert it to seconds. I say divide by 3,600. Now, the moment I reach this point, I'm going to reduce. So I'll say the 0 and the 0, 0 and 0. Then I remain with 900 divided by 36. So then you place your calculator. Then you say 900 divided by 36, which will give me 25 meters per second. So it means that the speed that the car is traveling with is 25 meters per second. And they told that is uniformly brought to rest. Members, when it is brought to rest, like we have said that our velocity is going to be 0. And now they're asking for acceleration. Now we shall say that acceleration is given by v minus u out of the time. But since we have said that it is coming to rest, our final is 0. So I will say 0 minus the initial one, which was 25, divided by the time, which is the 40 seconds. So here we shall end up with negative 25 out of the 40. Now I ask myself, what is 25 out of 40? 25 divided by 40, we shall end up with negative 0.625. And this is our meters per second squared. Now, when you look at our acceleration, you are not seeing that our acceleration is the negative. Now, the negative on our acceleration here, it shows us that it is decelerating. The velocity is reducing. Something is coming to rest. So meaning that the use of this negative you are obtaining, it is to show you that it is a deceleration. But when you are concluding, you will say now the car decelerated on 0.625 meters per second squared. Members, is that fine? Are we on the same page? Okay. It seems we are on the same page. Let me pick a hand. Yes, Emanuela.
Sir, where did you get the per squared, the meters per squared second?
We say that the SI units of acceleration is meters per second squared. You remember we said that acceleration is velocity out of the time, but velocity is given by meter per second out of the second. So which will give us meters out of second squared, which is meter per second squared.
Yes, I've understood now. Thank you.
Okay. Okay. Members, are we good to continue? Okay. Yes. Anderson, I gave you a chance. You are not unmuting. Elena?
Sir, is it possible to also change the 40 seconds into hours and then you use the very same method?
Yes, it is very okay.
Okay.
So you'll get the same answer. Okay. But now here, though it is not the best, that's what I want because it will not be in standard units. Yes, Anderson?
Excuse me, teacher. Sorry for taking you behind, but did you have 10 seconds in the last number?
Did we have 10 seconds?
Yes.
Okay. Yes, we had 10 seconds.
Oh, all right. Thank you.
Okay. Okay. Yes, Daniel. Daniel?
Excuse me, teacher.
Mm.
Teacher, about answering in standard units. Supposing the question has come when the units are not standard, do you have to change them and then you put them back, or you change and then you leave it?
You leave it like the way we have left it.
Okay.
Okay. So let me display one more number. And this is our number. So first write, and then we try it. That's right. I want everyone to first change for me the 72 kilometers per hour, the way we have done on our previous number, to meters per second. That is the first thing. Okay. Everyone, people got 20 meters per second. That is very good. 20 meters per second. I'm saying 20 meters per second in the chat. Okay, that is really very interesting. Yeah, 20 meters per second. Very good. Yes, those who are getting it, that is very nice. So that is the first thing we convert. Initially traveling at this. So members, it means that our initial velocity u is equal to 72 kilometers per hour, but we convert it. So to convert it, we shall say 72 times 1000 out of the 3600. And from the chart paper saying they are getting 20 meters per second, which is very okay. Now, can we go on members and calculate the retardation? Calculate it now. Gabjela?
Teacher, I'm done.
Okay, take us through.
All right. So they want the retardation, which is okay, something similar to the formula of acceleration. So we say A is equivalent to final velocity minus the initial
Okay.
divided by t.
Mhm.
So our final is unknown.
Now I want you to read the question. What
Oh, sorry,
unknown?
unknown.
It is?
It's zero.
It
It's a
is zero.
zero
Why?
minus those 20 meters we got.
Okay.
Divide by 5.
Okay.
So it's negative 20 divided by 5, which is negative 4 meters per second.
Squared. Yes.
Yes.
Okay, but now in our conclusion, since they have told us they want retardation, so we shall conclude and say it is 4 meters per second squared. Since the question asks for retardation, so you can drop the negative to find it, to just write the conclusion.
Yes. And excuse me, teacher.
Yes.
So sometimes when that negative is not there, is it right to add it?
When it, like in calculations, when you are dealing with the retardation?
Yes, and you get a plain 4.
Yes. Yes.
Okay.
Yeah, but that one is in the calculations. When they mention retardation, then you bring in the negative.
But when you're stating it, it doesn't need to be there.
Yeah, when you are stating it.
All right.
Okay, let me hope that is very okay. Then I'm going to ask you, calculate for me the distance and place your answer in the chat. Okay, I'm waiting in the chat. We are calculating our distance. Okay, Jeremy is getting 50. Jeremy is getting 50. Yes, Ellie?
Teacher, my answer is 50, and I used the third method.
Okay.
Yes,
Take us through.
plus 2as. So
Okay.
my final was 0.
Okay.
Then my initial was 20 squared plus 2 times negative 4s. So you have 0 is equivalent to 400 plus negative 8. Okay, negative 8s.
Okay.
So we subtract 400 on both sides. Then we divide each side by negative 8.
Yeah.
And you get your displacement as 50 meters.
Okay. Thank you. That is correct. Okay, thank you, Ellie. Members, let me hope we are on the same page. Okay, hope now we are good. Eric, a question? Okay, kindly take us. Yes, Eric?
No, sir, it's Martha, but my question is, what if we use the normal formula of distance, that speed times time?
Okay, now, when you look at what we have been given velocity and not speed. Are you getting it? So here there is nothing like speed, there is nothing like distance. We are dealing with displacement, we are dealing with time. And when you look at in terms of what you call vector and scalar quantities, that formula works when we are not considering anything like direction. We don't look at the direction. But since here they have even mentioned the retardation, meaning that we are looking at the direction. Distance doesn't look at direction. So here even you don't mention the negative if you are to use that formula. So that formula will not work at all.
Okay, teacher.
So you only use it when you have seen that in the question they have mentioned the speed, they have mentioned the distance. That's when you can use it. But yeah, there are very few cases where you will ever use it. going forward. Okay. Okay, hope you have finished to take a screenshot. If you have done so, we are going to end at this point. And so allow me to stop the sharing of my screen. Okay.